Okay, this is Geometry, Chapter 6, Section 6, Properties of Kites and Trapezoids. This is Part 2, so we're talking about trapezoids. So a trapezoid, as you know, is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is known as, it's called a base. Good. And the non-parallel sides are called, just like a triangle, legs, right? The base angles of a trapezoid are two consecutive angles whose common side is a base. So we have the base angles, angle A and angle D, and the other base angles B and C. If the legs of a trapezoid are congruent, the legs are congruent, then the trapezoid is called an isosceles trapezoid. The following theorems state the properties of an isosceles trapezoid. So this is strictly for isosceles trapezoids. Theorem 663. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. Angle AD, angle A and angle D are congruent, and angle B is congruent to angle C. They must share a base, right? Theorem 664, if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So if we can show that just one of the two bases has a pair of congruent base angles, then we can state that the entire trapezoid is isosceles. And finally, 665, a trapezoid is isosceles if and only if its diagonals are congruent. So if you know you have a trapezoid and you can show that the diagonals are congruent, AC is congruent to DB, then that trapezoid is an isosceles trapezoid. Using properties of isosceles trapezoids, find the measure of angle A. Angle A. Okay, we can see that this is an isosceles trapezoid, two legs which are congruent, exactly one pair of parallel sides. So if we know that angle C is 100 degrees, then we know that this angle, angle D, is also 100 degrees, right? And we could say that due to the fact that we have same side interior angles, we know that B and C are supplementary, as are A and D. Angles A and D are supplementary. So measure of angle C plus the measure of angle B equals 180. Same side interior angles theorem. So we can substitute the known 100 for angle C and find B. So angle B must be 80. Good. So if we know that angle B is 80 degrees, we can now say that angle A is congruent to angle B because we know that this is an isosceles trapezoid which is got base angles which are congruent. Therefore, angle A, the unknown angle, must be 80 degrees as well. Okay, let's use the properties of isosceles trapezoids to find B in this isosceles trapezoid. Okay, so FB is our unknown. We're looking for that. But we do know that KB is 21.9 and MF is 32.7. This entire segment is 32.7. We're looking for FB. Okay, and we know that KJ, that diagonal, is congruent to FM because these are diagonals of an isosceles trapezoid. Okay, which means that they are congruent. Not their angles, but their actual diagonals are congruent. Therefore, KJ equals the measurement of FM keep in mind we know the measurement of FM. It is 32.7, right? And so we can substitute that value for FM. Good. And then KJ, we know, is made of KB and BJ, right? So we can substitute that by segment addition postulate. And now we can substitute our value for KB and the value for KJ, right? To find the unknown segment here. Okay, and that unknown segment would be 32.7 minus 21.9 or 10.8. 10.8. Good. So that doesn't answer our question though. Our question was the length of FB. But how is this segment here, JB, related to FB? Congruent, right? Okay, so we can say that FJ is congruent to JF, FJ is congruent to JF, and our reasoning there is it's the same line, right? Or we have said reflexive. We can say angle KFJ is congruent to MJF, KFJ is congruent to MJF. These are base angles up here, base angles, right? And we can also say that KF is congruent to MJ. KF is congruent to MJ, right? And therefore they are equal, right? So we can say that triangle FKJ is congruent to JMF. FKJ is congruent to this other triangle over here. How are we naming that? JMF. JMF. Okay? Wow, this is an interesting way to say this. That's by SAS. And so angle PKF is congruent to BMJ. Corresponding parts of congruent triangles are congruent. BKF, BMJ. BKF up here and BMJ, right? Very good. And so we now know that angle FBK is congruent to JBM. FBK, JBM. Right? Okay, so we know something about these triangles as well, don't we? Okay, so KF is congruent to MJ. Isosceles trapezoids' legs are congruent, KF and MJ. KF and MJ. And triangle FBK is congruent to JBM. FBK, FBK, JBM. If that's true, then we know that these legs are congruent, right? And so FB is congruent to JB, which means their measurements are equal. And FB, therefore, also is 10.8. We substitute. Okay, so can you find the measure of angle F? And hopefully you see that because we have an isosceles trapezoid, we know that angle H plus angle G is 180, right? Same side interior angles theorem. And so the angle G equals 180 minus 49. So that would be what? 131. And because angle F is congruent to angle G, their measures are congruent. So angle F would be 131. Very good. Can we find KM? We know that JN is 10.6 and NL is 14.8. Can you find the other diagonal KM? Well, this is an isosceles trapezoid. So if we can find JL, then we can find its congruent diagonal KM. JL is made of JN plus NL, right? 10.6 plus 14.8. So we have 25.4. So Km must be 25.4. Very good. Now this is a little more fun. We're being asked to find the value of x so that this is an isosceles trapezoid. So if this is an isosceles trapezoid, what can we say about angle Q and angle S? They are base angles of the same base, correct? Which means they are congruent. So if we're asked to find x, we can set these two expressions equal and solve for x. And that's exactly what they do. So set them equal and pause the video, solve for x, and come on back. And hopefully you found 4 or negative 4. Very good. The midsegment of a trapezoid is very much like the midsegment of a triangle, but trapezoids are a little more sophisticated due to their two bases, right? So the midsegment of a trapezoid is the segment whose endpoints are the midpoints of the legs, just like in a triangle. And the theorem that goes along with that is the midsegment of a trapezoid is parallel to each base, and its length is 1/2 of the sum of both bases. Now in a triangle, recall that a midsegment was 1/2 of the base, right? So because a trapezoid has two, we're going to have to sum the bases, and the midsegment would be 1/2 of the sum of the bases. Find the length EF. Pause the video and come on back. Okay, we're simply applying the trapezoid midsegment theorem we just saw. We know the bases, so when we add them, their sum is, looks like 21.5. So EF would be 1/2 of 21.5. And so hopefully you have 10.75. Very good. In this example, we're actually given the midsegment. The length is 16.5. We're asked to find one of the bases, right? So we're going to start with our theorem that 16.5 equals 1/2 of 25 plus our unknown, right? Go ahead, pause the video and solve. And once you do, you should have 13. Go ahead and pause, give it a try, and come on back. Okay, and how much binding does Aaron need? About 191.2 inches. In this kite, find the measure of angle LHJ, and it is 81 degrees. PKL, down here, is 18 degrees. Pause and come back. The measure of angle WXY is 119 degrees. Find VZ. Segment VZ is 9.6. And here we are missing one base, right? We know the midsegment, but we are missing the base LP, which is 18. Excellent. Okay, and that wraps up section 6-6, properties of kites and trapezoids. Do your best on this and look forward to a fun test on chapter 6.